Morning, Tahmina Khan is here in TKMaths is fun. In today's video, I will explain to you two questions of probability. It is a topic of O-level mathematics, code is 4024. These questions I have picked up from New Syllabus Mathematics 7th edition. And before we begin, you can see on the top my website address, tkmaths.com, and my blog address, tkmathsisfun.blogspot.com. Do visit it. You will find it very useful in your learning process of mathematics. You will find the link of all my videos I have made so far, the solution of challenging question. This site is still under development. If you have any suggestions, please do write in the comments. So let's begin with the question. So it is question number 15, and it is talking about drawing and placing the ball into another box. So there are two boxes, A and B. So rather than reading the whole question, I'll explain you with the help of diagram. So the whole procedure is that from box A, you are taking a ball, putting it in box B, thoroughly mixing it, and then putting it back in box A. And then all the questions are about balls in box A, right? So this is the whole idea of the question. So let's draw this. It is very useful always that you sketch roughly or draw the diagram so it's easy to understand. For example, I have drawn here two boxes, A and B. And the number of balls in box A, I have mentioned here 7 blue, 5 yellow. So altogether 12. In box B, 3 blue balls, 7 yellow balls from here. So total are 10. Now, the experiment is about first time you are drawing from box A and putting it in box B. So it is understood that when you are drawing from box A, total number will reduce by 1 and it will become 11 after drawing, right? Not the first time I'm talking about. When you will put in it, now this will become 1 more. So total number will become here 12. And then after that, once you draw this ball, you put it back here. So this number is back to 11 at the end, 12 at the end, right? Now it depends if you are drawing a blue color ball and putting in it first time. Then of course this will reduce by 1 and this will increase by 1. Similarly, and yellow color will have no impact. So you have to think around it. We will see gradually, okay? So, and after drawing from box B, because that is your second draw, you are putting it back in box A. So this is the whole situation of the experiment. Now let's see here. For example, I have not written probabilities along the trees. I want to do it here with you. So you are drawing first time. So forget about this diagram. So let's hide this part of the diagram so that it doesn't confuse us. So suppose it is only this first time draw, right? You are taking a ball from here and putting it here. So we are talking about probability of drawing ball from here. Okay. If you draw blue ball from here, so what is the probability? Simple question. 7 upon 12, right? Okay. If you are drawing yellow ball first time, right? What is the probability? 5 upon 12. Simple. Now the ball you have drawn from here. Now this is the time to think carefully. The ball which you have drawn from here is going into this box. Okay. So now this will increase by 1. Now total balls are 11 in it. So when we will draw from here, now the denominator will be 11, not 10, because the ball you have taken from here is going into this box. Now, if you are taking blue ball from here and putting in it, so what is happening? This blue ball will increase by 1. It will be 4 now. So if you draw blue ball from this, now after thoroughly mixing it, once you have put this in it, so probability of blue ball is 4 over 11, right? This is all depending on first time what you have drawn from here. It's still the same situation because first time is telling me I have drawn blue ball and put it in box B. So yellow balls are same in number. So what is the probability of yellow ball? 7 upon 11. Because total number has increased, but yellow ball are same in number, right? Now see the second scenario. If the first time when you are drawing from here was a yellow ball, so suppose yellow ball is going first time from here. So what is happening here? Now this time, yellow ball will increase by one number, right? So this time yellow ball will increase by one number and it will become 8 yellow balls. And blue balls will remain same. So now if I ask you in the second row, which you are drawing from here, what is the probability of drawing blue ball? So in this box, you can see there are 3 blue balls out of 11. So you will write 3 upon 11. Whereas if I ask you what is the probability of drawing a yellow ball? In this box, it is 8 upon 11. So this is how you will complete your tree diagram. Now very important thing, because all the questions in the questions were talking about, if I show you the question here again, it was talking about with respect to box A, find the probability at the end of the experiment the box A has. So all these questions are related to box A. So experiment is done. You have taken ball from here, you have taken ball from here, and now you're putting it back here. So let's see one by one. This is all the situation of box A now. How many balls and what color of ball it has after the experiment. So let's say in this situation, you have taken ball B from here, right? So, I mean blue ball. This is representing blue ball. You were putting it and putting it back here. So what is happening? At the end, the blue balls in box A are same. It is 7 blue balls and 5 yellow balls. Make sense? Whereas in this case, blue ball is going from here. Let me erase this arrow, which may confuse you. So in this case, now blue ball is going from here, from box A, and yellow is drawn and putting it back. So blue is going and yellow is coming back. So what is happening? The number of blue ball is reduced in it, 6 blue balls, and yellow balls are 6 because blue gone and yellow coming. Okay, you can do this experiment with bag in your by taking one bag and putting balls in it. You will understand better if it is still not clear. Right, now let's see this situation. In this situation, what is happening? That you are taking yellow ball from box A. So now yellow is going from here, okay, first row. So it is 4 in numbers now. And what is coming back? Blue is coming back in the second row. So basically this is reducing and this is increasing. So it will be 4 yellow and 8 blue. Agreed? Now let's see the last scenario. Now what is happening? First time yellow is drawn. So yellow is going from here. So 1 yellow is less. But at the same time, yellow is coming back. When you draw from here and put it back here, it is yellow ball. So there is no impact, no change. So it will be 7 blue and 5 yellow. So now this information is telling us number of balls in box A at the end of the experiment. We drew from here, put it here, mixed it, and took one ball out and put it back here. So this is giving you the complete situation. Now let's answer the questions. Okay. Okay, the first question was, at the end of the experiment, box A has more yellow balls than blue balls. Is there any situation where yellow is more than blue? If you see here, no, 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 no. So there is no such situation in the experiment when yellow will be more in numbers. So we will write answer is 0, right? Now it is saying 7 blue and 5 yellow balls. So is there a situation at the end that box A has 7 yellow balls, 7 blue and 5 yellow balls? Oh yes, it is this situation and this situation. So this situation is because of drawing blue and putting back blue. Drawing yellow, putting back yellow, right? So what is this? Blue and blue. So multiply this probability. Or second situation is 5 into 5 over 12 into 8 over 11. So once you have identified the situation, you will simply multiply the probability along the branches. So I've multiplied this by this and this by this and added up because there are two such situations. Along the branches you multiply and different results of the branches you add up, right? Makes sense. Now, third scene. Find the probability that at the end of the experiment, box A has twice as many blue balls as yellow. So blue are double in numbers. Let's check the situation. No, no, yes, here is the situation. Blue are double in number compared to yellow because 8 is double of 4. So it is talking about, sorry, it was erased. So it is talking about this branch. So I will say, yes, the situation is first time yellow, second time blue. So 5 over 12 into 3 upon 11. And then you multiply. So you will get your answer, right? So this is the situation to answer all the questions. Let's see the second question, which is number 17 in the book. This is talking about eruption of volcano in 3 countries. And the probability of eruption is given to you of country A, B, and C. Now there are 4 parts. Volcanic eruption will occur in all 3 countries. So what does it mean? It means, okay, before answering this question, I will put it down like this because I will use this information. So probability of eruption in country A, country B, country C. And we know 100% probability is 1 always of any experiment, right? So if I minus 1 minus 0.03, what will I get? That volcano in country A does not erupt, right? So I'm putting down this information also here because I will need this in my experiment. Sometimes it is asking no eruption, 1 eruption, 2 eruption. So I have to use all this information. So I have done this separately here. So this is no eruption, dash mean opposite of what you're talking about here. Okay, so question is saying volcano eruption will occur in all 3 countries. It means A, B, C, erupt, erupt, erupt. And these are the cases of eruptions. So I will simply multiply them and I will get the answer. That volcano erupt in all 3 countries. Okay. No eruptions will occur. So in any country, no. So what it means? Country A, no eruption. Country B, no eruption. Country C, no eruption. And we have taken out the probability of these. 1 minus this, 1 minus this, 1 minus this. So you will simply multiply them and you will get the probability that no volcanic eruption happen in any country. Okay. I hope it is clear so far. So if you write down all information in the beginning, it's easy to plug in values then, right? And there are less chances of error. Okay, 3 part. There is at least 1 volcanic eruption. Now this is important, at least 1. Now there are ways to do it. For example, at least 1 eruption means what? It may occur in 1 country eruption, maybe in 2 countries, or maybe in all 3 countries. What case we are not considering here? Because when we are talking about eruption in countries, there are basically how many cases? Maybe no eruption at all, maybe eruption in all, maybe eruption in 1 country, maybe eruption in 2 countries. There are 4 cases which are possible, right? So when it is saying at least 1, it means I'm not talking about the case when there is no eruption. So the easy way to solve this question is that from the 100% probability, which is 1, you minus the probability that no eruption will occur. And we have solved this in previous part. So we are simply subtracting and getting the answer. Whereas the longer method is that you consider all the cases and add them up. I have not done here, but I have explained here. You can try it out. You will get the same answer. So the cases of one country eruption and two no eruption. So you will take all the cases. Okay, B does not erupt, A and C erupt. C does not erupt, A and B erupt. So there will be three cases here. Or two countries erupt, one does not erupt. So three cases of this also, one by one consider all countries. And all does not erupt, right? So you do it separately or straight away you do. What do you do? One minus no eruption, okay? Okay, so sorry, I'm saying three erupt. So it will be, this dash will not come here. Let me just erase it, sorry. Right? So the cases are one erupt, two did not erupt, two erupt, one didn't erupt, and three erupt. So you find out all this and then add it up. So this is a longer method to do it, and this is a shorter method. So be intelligent and use probability accordingly. Okay, so last part of the question. There are exactly two volcanic eruptions. Now, so you will consider which cases? A, B erupt, C did not erupt. Or A, C did not erupt, B did not erupt. Or A did not erupt, B and C erupt. So these are the three possibilities, and you will write their probabilities, you know, A and B from here, and C bar is opposite of it. So 1 minus 0.3. Similarly, I have filled up all the probabilities, and all were written on the first slide when I was writing down the values, and then multiply and add up. So you will get the possibility when exactly two volcanic eruption will occur. Or the other way of doing it is that 1 minus probability of only one eruption minus all eruption minus no eruption. So you can write down the cases, multiply, add, whatever you want, but this is easy in this case. So this is how you figure it out, and I hope it makes sense to you. So thank you very much for watching. If you learn from it, like it, please press like and subscribe button. Share it with your friends. They may also get benefit out of it. And do write your positive comments. It will help to make more useful videos. Thank you very much once again. Take care. Allah Hafiz.